Hello and good day, geometry. What's going on? We're going to continue PO24, which is proofs with triangles, proving that triangles are congruent. And basically, I'm just going to run through 4 of them here, just so you can kind of get the process down. I'm on part 3. We did part 1. We did part 1. Or part 2, rather. I went over just the first proof there. I'm going to leave the other 3 for you to practice with, and then I'll go over 4 of them in part 3 in this video, and then you can do the ones in part 4 as well to prepare for the test. On the test, your test questions are going to be similar to PO16, to where I'm going to kind of give you the statements and you're going to be giving me the reasons why we're allowed to say it. Okay, so kind of a similar setup as in PO16. So you need to know your postulates, theorems, definitions, all those things we've talked about up until this point, anything that's inside your toolbox. But again here, I want to reiterate that when dealing with triangle congruency proofs, okay, we really only have, sorry, I didn't put my pen down before trying to scroll. We really only have 5 options that we can use to prove the triangles are congruent. And they are side, 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 angle, side, angle, side, angle, 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 side, and HL. Okay. And by the way, just so you know, my favorite sauce at Buffalo Wild Wings is Caribbean jerk. All right. So we are going to set up our statements and our reasons here. And notice there's no given statement, only a proving statement. It says prove that segment LM is congruent to segment LQ. Well, LM is this segment there, LQ is this segment there. It doesn't explicitly say that we're solving or that we're proving triangles are congruent. However, notice that LM and LQ are corresponding parts of the 2 triangles that we do have here. So we are still going to be proving these 2 triangles congruent, because we can then use their corresponding parts to get the specific part of the triangle that we want. So the fact that there's no given statement is okay, because our first thing here is still going to be what we're told. We're told that segment NM is congruent to segment PQ. And we're told that angle N is congruent to angle P, okay? And instead of given, we're going to write marked, because it's marked in the diagram. And if you want to pause the video here and kind of see if you can do the proof yourself and then go back and watch it and see how well you did, that's certainly an option, okay? But like we talked about yesterday, we're looking for, again, these 5 things, three parts. NM and PQ, well, there's one side. Angle N and angle P, well, there's one angle. I mean, I've got one side, one angle. I can eliminate side, side, side. I'm not going to be using that here, okay? I can eliminate HL. I don't have right triangles here. So basically what I'm looking for now is I'm looking for a second side or a second angle. So I go to my diagram and I say, okay, what information do I have here that I could use to say that a second pair of sides are congruent or a second pair of angles are congruent? Some questions you might ask yourself here. Can I use the reflexive property? That's a common one. Do I have parallel lines? That would help me with angles. Do I have vertical? Oh, yeah. All right. I've got vertical angles here with NLM and PLQ. So my second step is going to be that angle NLM is congruent to angle PLQ. And I can say that because of vertical angles. And what I just found for myself is I found another angle. Okay? Now there's no side angle theorem, right? So I have to kind of take a look at which one I'm going to use here. I've got two angles. I've got one side. Is that side in between my congruent angles? Is that side included? No. So I'm going to be using angle side here. So step 3, I can say that triangle NML is congruent to triangle PQL because of angle side. Now, I'm not done, right? Because my proving statement is LM is congruent to LQ. But now that I've got the triangles proved congruent, I can say that segment LM is congruent to segment LQ because of corresponding parts. Because like we talked about, if you can prove that two triangles are congruent, all of their corresponding parts are going to be congruent. You only need 3. That's why I have side, angle, side, yada, yada, yada. But if you can prove the triangles are congruent, then all their corresponding parts are going to be congruent as well. Okay? All right. There's the first one. Second one. I'm going to put these back up here again. Side, side, side. Side, angle, side, angle, side, angle, angle, side, and HL. So my goal here is to prove that angle S is congruent to angle U. Okay. Now, sometimes kids see that you've got the two sides there, and they'd say that the triangles are congruent because of side, angle, side. They'll mark angle S congruent to angle U. Well, remember, that's what we're trying to prove. We don't know that yet. Okay, we can't mark it as true until we've proven it. So your proving statement will always be your very last statement. Okay, you can't use it in your proof someplace else. But I've got my statements, got my reasons, and before I start, I was just like you to know that my favorite childhood book was The Phantom Toll Booth. Highly recommend it. Okay. Again, I don't have a given statement here. But I do have stuff that's marked, right? I've got ST is congruent to UV, and I've got SV is congruent to UT. And it's not given in a given statement, but it is marked. So that's where I'm going to start. And now I kind of take an inventory check and see where I'm at. What do I have? What do I need? Okay. I've got one side. I've got a second side. So either I'm going to be looking for an angle here, which I really don't have any information about the angles. I don't know for a fact that ST and VU are parallel, so I can't really use those. So I'm going to put my focus here on side, side, side. Can I get that third side of these triangles? Can I say that it is congruent? And I'm talking about the third side here, VT and TV, which, again, kind of run through your common ones. Reflexive, vertical, parallel, it's reflexive, right? VT is congruent to TV because of the reflexive property. Okay. And if you're wondering why I didn't put VT as congruent to VT, remember we have to line up those corresponding parts. Okay, that order does make a difference there. VT on the top triangle is starting at point V, which is between our, or it's next to our single mark side there. So for the bottom triangle, that same side, I've got to start with point T, because that's also next to our single mark side there. So that's why the order there is the way it is. But I've got my third side. Okay, so I can say the triangles are congruent. I've got triangle STV is congruent to triangle UVT. triangle, because of side, side, side. And now that I know the triangles are congruent, now I can go ahead and say, okay, I know that angle S is congruent to angle U because of corresponding parts. Okay? And just in case you were wondering, I did have a childhood pet, a dog named Baron. All right, going on to the bottom two here. Okay. Here I do have a given statement. I'm given that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, and I'm proving that triangle BCE is congruent to triangle DCE. So first, let's just identify what these pieces are. Where is triangle BCE? BCE is this triangle here in green, and DCE is this triangle here in blue. I like what I see so far here because I already have one pair of angles, right? Angle 1 and angle 2. I've already have those marked or given congruent to me. I'm turning my cursor up here. Given congruent to me in my given statement, and side CE is a shared side, right? So I already have kind of two of these pieces here. I just got to get that third part to say that those triangles are congruent. So statements, reason, number 1, angle 1, congruent to 2, angle 3, I'm going to scoosh it in here, congruent to 4, and this time it is a given statement. Okay. Step 2. All right. Well, I'm just going to get out of the way. I'm going to say that CE is congruent to CE. It's congruent to itself. And in this case, it is CE and CE because of the way the triangles are positioned there. Okay. But that is reflexive. So already I've got one angle and I've got one side. And so I'm looking for another angle, another side. Okay, where can I go from here? Well, they wouldn't give us that, or I'm not going to give you, that angle 3 is congruent to angle 4 if it wasn't going to be important here. Because instead of putting my focus on the triangles I'm going to be proving initially, I want you to take a look at something else. Take a look at this top triangle and this bottom triangle. Why would I care about those? Why would I care about those? Well, if I can prove those two triangles are congruent, then through corresponding parts of those two triangles, I'm going to get my third side for the triangles I actually want. So we're kind of taking an indirect approach here. We're going to prove those larger triangles are congruent to get those corresponding sides and ultimately what we want for our smaller triangles. And getting these two triangles congruent isn't that difficult. I already have two angles with angle 1 and angle 2 and angle 3 and angle 4. And then they have a shared side. Notice where my red and black overlap there. CA is a shared side. So my third step, I'm going to say that side CA is congruent to side CA because of the reflexive. And that actually gives me my third part for that top and bottom triangle. My fourth step, I can go ahead and say that triangle CDA is congruent to triangle CBA because of what? If I just proved this side congruent because of the reflexive property, what's that going to be for that top and bottom triangle? Angle, side, angle. Right? Oh, my favorite movie, by the way, Truman Show. Haven't seen it, recommend it. Truman Show. But now that I've got that, step 5, I can kind of go back to this here, and I can say, well, because that top and bottom triangle are congruent, that means that CD is congruent to C because of corresponding parts. Okay? Which happens to be my third piece of the triangles I want to prove are congruent. So what do I have here? I've got angles 1 and angle 2, which were given to us. I proved that CE is congruent to CE because they're reflexive. And then through corresponding parts, I proved that CD is congruent to CB. What do I have? I have 2 sides and an included angle. Step 6, I can indeed say that triangle BCE is congruent to triangle DCE because of side, angle, side. Okay. Have I told you my favorite song yet? Karma Chameleon by Culture Club. Comma, 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 chameleon. Gets stuck in your head. Anyway, so there you have it. I was going to do all 4 of them, but I think this video is getting a little bit on the longer end. It is 9:37 at night. I still have to eat, so I'm going to call it quits here. Your homework is a Google quiz. You can go ahead and jump on over there for that. Make sure you do get 100%, and then practice these other proofs. Okay, practice, practice, practice. That's what it will take. Next week, we've got 1 objective left to cover. I'm not exactly sure how it's going to look as far as meeting live after school or a video. I think I'm going to do a video for PO25 on Monday, and then we can meet after school to go over the practice test Tuesday or Wednesday. And then your tests will be after school Thursday or Friday. You can pick which day to stay after. I've got other tests going on that week too, so I have to make sure that I can be there after school for other kids that may want to go over things. So maybe we'll just make our day to go over the practice test on Tuesday. Anyway, I'll send something out. I shouldn't say things as I'm working through them in my head. So hop over to the Google quiz, take that, have a great weekend, practice, practice, practice. That's how you math. Do not forget to like and subscribe.